anyone figure out which of those graphs goes with the equation k of x equals 2x minus 4? Eli?
C.
Very good. Why is it C?
Because -4.
Ah.
Intercept.
The -4 is the y-intercept.
So I looked at whichever one is -4, and the only one that's -4.
There he is. The only one that crosses the y-axis at -4 is C. So the correct match to little a was big C graph. What about little b? Sabrina, what'd you get?
For B, I got A.
Why?
Because it was the only one that went to 5
Correct. Did we need to use the slope for any of these problems? No, siree. All we needed to look for was the intercept. Our y-intercept should have been 2. The only graph that crosses positive 2 is capital A. What about C? Did anyone get C? Carl, what'd you get?
D.
Excellent. Why?
Because it's the only one that passes away. It was honestly process of elimination.
So you matched up all the other ones and then you matched those two together? Well, let's think about it. Do you see the +4 that I circled?
Yeah.
That means that our y-intercept is 4, right? Why would that match to D? Why would that match to D? Does anyone else know? Joseph?
Because D is showing a positive y-intercept.
Very good. D is showing a positive and specifically +4 as the y-intercept. Excellent. Okay? So that's why D belongs with C. And then for little d, did anyone get that one? Process of elimination. What's the answer? Diana?
B.
B. Very good. Now, can anyone explain why it's B? All good. Layla? If you answer my question.
What?
It's a sort of riddle.
Why is the last one capital B? Or the restroom. Grayson, go ahead.
So, what was the question? Okay, wait. Okay, hold on. So, the y-intercept is -2.
Mhm.
B, process of elimination is the only one left. And it has y-intercept of -2.
Very good. Layla, you can go at the end of the period. Okay, so,
Wait.
To-
Can I answer that? Can I go to the restroom?
sure. Okay, since today what we are learning about is something called transformations, okay? We're going to start super basic in terms of transformations. We're just going to be moving things around from left to right, up and down. And then later on, we're going to shrink and expand our graphs. But that's a little bit later, okay? For right now, we're just going to move everything left or right or up or down. All right, the first thing that I want you guys to do on this page, I need you to highlight that our parent function is f of x equals x, okay? That is the parent of all parent functions. It's the most generic. It's when our slope is 1 and our y-intercept is 0, okay? Now, it says a transformation changes the size, shape, position, or orientation of a graph, okay? So we're going to be learning about transformations that do all of those. But the first one, the most basic one, is something called a translation, okay? And a translation is when you move something in one direction. You don't change the size of it. You don't change the shape of it. You just move it from one point to another, okay? There's 3 different kinds of moves. We can either move something left, we can move it right, we can move it up, or we can move it down, okay? So anything that's horizontal would be left to right, okay? So a horizontal translation, it's written in the form y equals and then f of x minus h, okay? The big thing that you guys need to notice here is that we are subtracting h from every x value, okay? That is a horizontal translation of the graph y equals f of x, which is our parent function, where h is not equal to 0, okay? So think of, let me stand right here, and think of me as your parent function, okay? Me standing nice and tall. If I take one step to my right, Did my body change at all? Did my position change? Yes, I moved over, right? That's exactly what a translation is. It's just saying, okay, do you see how the black graph on your page in the horizontal translations looks exactly like the blue and the red one? It's just moved over a little bit to the left and a little bit to the right. That's what a translation is, okay? So when you move it to the left, in red, I want you to write that this is a left shift, okay? We shifted our graph, only shifted, we didn't change its direction, we didn't do anything, we just shifted it to the left. In the blue, I want you to write that that is a right shift, okay? And we're shifting it by the value of h. So whatever that value is that you're subtracting from x, that's how much you're shifting your graph. Okay? Take a look at the vertical translations, okay? The graph of y equals f of x plus k is a vertical translation of the graph y equals f of x, okay? Highlight y equals f of x plus k. And then circle the plus k. Oops. Can someone tell me, look at the two equations that we highlight for a horizontal and a vertical translation. Does anyone notice the difference between those two? Look at the two equations for a horizontal translation and a vertical translation. What's the difference, Layla?
How it's subtraction and addition.
Okay, one difference is that one's subtraction, one's addition. What's another difference?
So
Sabrina?
there's no, you have to put together f of x and the other one is already together.
Very good. F of x, we're subtracting h inside the parentheses. Do you guys see that? For the one over here? For the one over here, is the k inside the parentheses? No, it's outside, okay? That's a big difference, and we're going to see that down below, okay? So whenever you have a graph where you're adding k and your k is outside the parentheses, that's going to be a vertical translation. So in the blue, I want you to write that it's an upshift. And in the red, I want you to write that that is an example of a downshift, okay? Okay? So you're either shifting up or you're shifting down. But look at those two equations, those two lines, compared to the parent function. Did it change at all the actual look of the graph? Like how the line looks? No, right? It's the exact same line, it's just shifted a little bit up to get the blue one and a little bit down to get the red one, okay? Now, we're going to do two examples where we're going to find out the horizontal and the vertical shift together, and then I'm going to leave the next two examples to you guys to see if you were paying attention, okay? All right, so go ahead and scroll down a little bit, okay? It says graph and describe each transformation. Let f of x be 2x minus 1, and then our transformation is going to be g of x equals f of x plus 3. Circle this one in red, circle this one in black. Okay? So f of x is going to serve as our parent function. Write that in there. This is our parent function. How do we know that it's our parent function? Well, look at g of x. You see how g of x depends on f of x plus 3? Okay? You need to start with your parent function, and then your transformation is based off of that function. Okay? So, if f of x plus 3 is our transformation, let's start with the parent function, which is f of x, and let's graph it. Does anyone know how to graph this parent function? F of x equals 2x minus 1. Dana, how would you do it?
Well, first, don't you add the fx to the equation, so it'd be gx equals parentheses 2x minus 1 plus 3?
I love that. You said that. But let's graph the parent function first. That's an awesome connection. Sabrina? Why?
Because it's
What's that form? Grayson, help her out.
Slope intercept form.
Good. This is in slope intercept form. So the information that we know right off the bat is we should know our slope and we should know our y-intercept. Who can tell me what the slope is of our parent function? Eli? 2, or 2 over 1. Excellent. Does anyone know the y-intercept? Layla? -1. No. So, if our y-intercept is -1 and our slope is 2 over 1, let's just graph that. So just like Sabrina was saying, at -1, we're going to put a dot. Make sure you're doing all of this in black, okay? Because this is our parent function. If our slope is 2 over 1, what should we do from this point? If our slope is 2 over 1, what should we do from this point? Eli? Up 2 and then to the right 1. Perfect. So our next point is going to be here. And let's do it one more time. Up 2 units to the right 1 unit. Our next point should be here. So we've got 0, -1. The next point is 1, 1. And then the last point is 2, 3. Now, you guys can draw a straighter line because you're in notability, but draw a straight line through all of those points. And then at the top, label it your parent function. Okay, let's take a look back up at our transformation. So our transformation is saying, okay, take f of x and add 3 to every single value, okay? Now, this +3 indicates a vertical shift. So underneath the red circle, right, that this is a vertical shift. Of 3 units. Okay? It's a vertical shift of 3 units. Okay? The reason it's vertical is because the 3 is not inside the parentheses, right? Do you see how the 3 is being added to f of x, not x? So remember, look back up at our core concept, right? Do you see when when it was plus k outside the parentheses? It's a vertical. When you are adding or subtracting something inside the parentheses, it's going to be a horizontal shift, okay? So this is going to be a vertical shift of 3 units up because it's +3 as well. So look how we do it. Every single point, we're just going to move it 3 units above the previous point. So take 2, 3, move it 3 units up. Take 1, 1, move it 3 units up. Take 0, -1, move it 3 units up. And then put different points at each of these. And then you're just going to draw a line that goes through all of those. This is what we call our transformation. G of x equals f of x plus 3. Okay, now let's label these points. What's that point all the way up there in red? What's the coordinates of that point? Carl?
2, 6.
2 comma 6. What are the coordinates of that middle point? Carl?
2, 4.
2 comma 4. Oh, not 2 comma 4. 1 comma 4. Do you see that? And then what's the last one, Carl?
-2. No, 0 comma -2.
0 comma Layla?
Oh,
Positive 2. Okay? Now, your job within your group,
Oh my god.
3 is added to all the blanks.
increase by 3.
So much.
That's supposed to be increase. My handwriting is awful. Okay? Now, why do you think the x values stay the same, but the y values increase by 3? Joseph?
because they're only going up.
Correct. Do you see how all of our arrows are straight up? So we're not changing the x value at all. We're just moving our graph up 3 units for each of those points, okay? We're going to do one more example, and this is going to be a horizontal shift. And then I want you guys to try 2 on your own, okay? Let's take a look at number 2. It says graph, so we have the same parent function. If you guys want to copy and paste it, that's fine. I don't have the ability to do that because I'm working in Explain Everything. So I'm just going to have to copy down my parent function again, okay? So the points were 0, -1, 1, 1, and 2, 3. 0, -1, 1, 1, and 2, 3. 3, 1, comma 1, and 0, comma -1. Oops, -1. Okay? We're going to draw that line through all the points, and we're going to label this our parent function. Okay. Now, the next thing that's happening in this example is h of x, make sure you circle this one in blue, is equal to f of x plus 3. Compare number 1 and number 2. How are they different? What's the difference in number 1 and number 2? Diana?
The x is in parentheses with the 3.
Correct. The 3 is now being added inside the parentheses. Do we see that? Now, I want you to draw a little box around the x, the plus, and the 3. I'm going to show you guys a little trick, okay? This area in between the parentheses, think of it as its own little world. And we call that world opposite world. Just bear with me. Okay? We call that opposite world. Okay? Now, how opposite world works is anything that happens in opposite world, it's not going to be what you think. So if we were to add 3, right? We know that this is a horizontal shift. Because if you remember from our core concept, right? If you're adding something and it's inside those parentheses, it's going to be a horizontal shift, right? Now, when you plus 3 horizontally, right? Would that indicate that we should move our graph, if we're adding 3, to the right or to the left? If we added 3. Carl?
Right.
To the right. That's what most people would think, right? If you're adding 3, you're going to move your graph to the right. Since it's an opposite world, guess where we move it? To the left. Okay? So, you're going to write that this is a horizontal shift, 3 units to the left. Okay? Now, I'm going to explain why it's called opposite world. Okay? But I want you guys just to know that if it's inside parentheses, that world inside the parentheses is called opposite world. Okay? So instead of moving 3 units to the right, which we normally would do since it's plus 3, we're actually moving 3 units to the left. So we're doing the opposite of what we should do. Okay? So look what happens. Every single point, we're just going to take an arrow and move it 3 units in the other direction. 3 units to the left, 3 units to the left. We have 3 new points. And we're going to draw a line through those 3 points. Let's put our coordinates. The first one is -1, 3. The second one is -2, 1. And the last one is -3, -1. This is g of x equals f of x plus 3. Okay? So we moved it 3 units to the left. Does anyone see the pattern in the coordinates? Do you remember how we noticed a pattern in the last coordinates? Does anyone notice the pattern in the blue coordinates? Carl, what do you think it is?
Take away 1 at a time for the x and y, and then for the y, you take away 2.
That would be the slope. You're close. But you're saying the slope for like the black line, it goes down by 1 and then,
Oh, I was talking about the blue line.
yeah. Zoe, do you see it? Okay, so y values are staying the same. What's happening with the x values? Mm-hmm. Excellent. The x values decrease by 3. Eli, were you going to say the same thing? So you guys are doing the next 2 questions, the following 2 transformations. All right, now, what kind of transformation is g of x equals f of x minus 2? Vertical, good. How do you know? How it's written, because the 2 is outside the parentheses. Let's be specific. Now, be more specific about vertical. How am I going to move my graph?
Down to.
There it is. Down 2 units. Okay. Now, someone else help me graph the parent function. Zoe? Good. How'd you know that? No, you don't just do. How did you know that the slope was 3/1? Why'd you pick 3 and not 1? Yep, it matches up with the m. That's our slope. Okay, what else do you know? Excellent. Y-intercept is 1. Okay, can we graph that? Help me. Dot on the 1. Yep. Why do I do that? It's a positive. What else? Rise over run. Good. So let's do it one more time. And we should get these 3 points. Okay, let's label this our parent function. And then I'm moving everything down 2 units. So how many groups, honestly, moved everything down 2 units and your transformation looked like this? Excelente. Good work, peeps.
Can we get candy?
No.
I think we should. I think.
You guys always think you guys should get rewarded, okay? And so we're going to label this. How many people labeled their transformation g of x equals f of x minus 2?
What if it isn't a reward though? What if it's just a snack?
Okay? All right, for the second one, parent function's the same. Okay? If you did, you would have gotten what, like 2, 5, 1, 2, and 0, -1. And then these were 0, 1, 1, 4, and 2, 7. Yes.
Are there
Yep.
quiz or a test that's coming up for this? If we don't label it, will we get points off?
It'll tell you to label them.
Okay.
So if you don't follow the instructions, then yes, you will get points off. Okay? So remember how descriptive we were on the quizzes with our instructions? I definitely upped my game in terms of how descriptive I was. That will... All right. Let's do the second one. So parent function is the same. 0, 1, 1, 4, 2, 7. 0, 1, 1, 4, 2, 7. Draw a line. Oops, not an eraser. This is my parent.
Can I go now?
Yep. Okay. What kind of shift do I do when h of x equals f of x minus 2? What kind of shift do I do for the second one? Diana? Horizontal. How did you know?
Because I saw parentheses and I figured it's horizontal.
Very good. The minus 2 is inside the parentheses. But here's the moment of truth. Is it a right or a left shift? Sabrina? Very good. Why is it a right shift? Why?
Because it's negative, like it's subtracting 2, so it's in the opposite way.
Very good. We're in opposite world here, right? So normal people would take -2 and move to the left 2 units, right? But since we're in opposite world, we're actually moving to the right. A la derecha. Okay? So move every single point 2 units to the right, 2 units to the right, 2 units to the right, and you should get these 3 points, and your graph should look something like this. Your points should have been 4, 7, 3, 4, and 2, 1. What's confusing? This lesson?
Yes.
Okay, the next type of transformation that we are learning about is something called a reflection, okay? Now, when you hear the word reflection, what do you guys think about?
Like
What do you guys think of? Eli?
I was about to say reflection, but I can't say that. The reverse,
Okay, reverse. What else? What else do we think of when we hear the word reflection? When we hear the word reflection. Grayson?
Not a copy, but
Well, where do we see our reflection? In a mirror. Okay? So a reflection is the transformation that flips a graph over a line called the line of reflection. Okay? So, in every single one of our graphs that involves a reflection, okay, we're going to have a line of reflection and we're going to put it as a dotted line. Okay? That dotted line will refer to that line as the line of reflection. Okay? Now, there are 2 types of reflections. There's a reflection over the x-axis, which is when we make y equal to negative f of x. And there's a reflection over the y-axis when we make y equal to f of negative x. Okay? So all you need to do is either make x negative or f negative, and you're reflecting it over an axis. Okay? So, in the example where we are reflecting over the x-axis, I want you to draw a line of reflection, a dotted line, at x. Okay? Every point on your black line is going to be reflected over that line of reflection, okay? So let's say we had a point up here, okay? The point on the red line is exactly the same distance, but on the other side of that line of reflection, okay? Let's take a point down here, okay? We're reflecting that point all the way over the line of reflection to the same point on the other side, okay? So essentially, if you do that for every single point of the black line, you end up with the red line, okay, where you flipped it over the x-axis, okay? Now, let's take a look at the reflection of the y-axis, okay? So, draw a vertical dotted line on the y-axis. Every point on the black graph flipped over this line is going to be the mirror image on the red line. Okay? And if you did that for every single point on the black line, you would end up with the red line. Okay? Now, the easy way to remember this, or to know what to do, is you're just multiplying the outputs by -1, which changes their signs, or you're multiplying the inputs by -1, which changes their signs, okay? Now, once we do an example, it makes a lot more sense, okay? But I do want to point out the actual concept of this lesson, okay? Or this part of the lesson. New? Oh. Reverse and mirror. Okay. A reflection over the x-axis. So, let's try one example. We're only have time for one, and then we have to end, okay? Okay, so again, f of x equals 1/2 x plus 1. Then we're going to graph g of x equals negative f of x, okay? So, let's take our parent function and let's graph it, okay? Okay, so our parent function is 1/2 x plus 1. How would I graph that? Joseph?
You would put your y-intercept at 1.
Okay.
And then go up by like 0.5 over 1.
Okay.
And then you get 1.5 over 1.
So my intercept is 1, and then my slope is 1 over 2. So instead of going up 1/2, I'm just going to go up 1, but over how many? 2. So let's go up 1 to the right 2, up 1 to the right 2. Grayson, what's up? Oh yeah, you're good. Okay. So from here, we draw a line through these points. This is our parent function. Okay. Now, let's label these points. The first one's 0, 1. Second one is 2, 2. And the third one is 4, 3. Are we all good on getting the parent function down? Yes or no? Yeah? Okay. So, once we have the parent function, remember, when we have g of x equals negative f of x, that is, so we're going to find our x-axis and draw a line of symmetry. So draw a red dotted line on your x-axis. So that's my line of reflection. Okay, now this is the part where I need you guys to pay attention, okay? Every single point, we're gonna reflect over that line, okay? So this line is gonna look the same thing, just reflected onto this side when we're done, okay? So every point, we have to find the distance it is from that line and move the other way across it, okay? So 0, 1, right? How far is 0, 1 from the line of reflection? Allie?
0, -1.
It's 1 unit away, right? So if we were to move 1 down, we would get to the line, right? Move another 1 down, and that's your new point.
Okay, here's the next one would be a -2.
Good.
2, and then the next one after that would be like right there. Lower. Right there.
Yeah. So we're just moving. See how we move down 2 to get to the line? We move down another 2. We move down 3 to get to the line. We move down another 3. Draw a line connecting all of them. Now, which point didn't move? Which point did not move? Ooh, Cooper says -2, 0. Do you guys see how this point did not move? Can anyone tell me why it did not move? Yep.
Just on the x-axis.
It's on the line of reflection. Very good. Very good, David. Okay? Now, let's plug in. Let's figure out what the coordinates are and see if you notice the pattern. Okay? So 0, 1 became what? What's the new point? 0, -1. What was the second point? 2, and the last point? 4, -3. Does anyone see the pattern? What's negative? The y values are all negative, okay? So it's the same thing, just the y values became negative. Just write y values, change sign.